Alright, so today we're going to cover the basics of the GTAW process, otherwise known as TIG welding, otherwise known as heliarc as well. So we know that it goes by a few different names, and so we're just going to cover the basics of things, how to get started, what we're going to be doing on that first day of class. And so make sure that as I'm going through this, have a pencil, have a notebook with you. That way you could write down some of these notes, because when you do get to class, I will expect that you bring this notebook with you every single day. And so if you have basic questions, you'll be able to easily refer to that notebook and look at your answer from there. That's not to say that I'm not going to help you, that I don't want you to ask me questions. Absolutely, I want you to come to me if you have trouble. However, when it comes to trivial stuff, where you could easily just look at your notes and look at a number and like, oh, okay, that's what I'm supposed to have my machine set at, or that's the amperage that I'm supposed to be welding at, or just basic little things like that. I want you to be able to refer to those notes and then go from there. So let's get going here. And so just a little bit about the background of this process. I know that before we covered a little bit about the safety part of it, but not so much as to what this process really is. So we know that we still have an electrical arc just like before. We know that we use a shielding gas, and that's really all about that we know about it. And we know that it doesn't have sparks, right? But just a little bit about it. Again, we know this already. Tungsten inert gas welding, we know that it's referred to TIG. We know that it uses a shielding gas. Very, very basic stuff. Nothing too crazy. And if you ever wondered what this process looks like, it looks just like this. As crazy as that may look, that's not something that you typically see or think about when you think about welding. That's an extremely clean process, right? This is actually my favorite process to teach, so I'm very excited to teach this class. So some of the advantages of it. So the main thing is that this process creates some of the most superior welds out there as opposed to other welding processes. And so why can't we do this? Well, we have so much control over the process as opposed to other processes. And so for example, we discussed before that it requires a lot of dexterity with your fingers, and that's because you have to be extremely precise with your welds, or else if you're just kind of shaking a little bit, right, or a little bit nervous, or for example, or even if you're holding that torch a little bit too tight, it's going to cause your hand to shake. You're not going to be as precise. But a good TIG welder will always have superior quality welds. If you've ever seen any sort of welding done on, for example, exotic vehicles, or like a custom vehicle work, things of that nature, or even like, for example, nuclear work, critical work, where, for example, aircraft industry as well. Most of those welds are going to be done with TIG welding because of the precision that you can get with this process. It's going to have minimal amount of smoke, fumes and sparks and things like that. Again, as you saw in that picture, there wasn't really a whole lot coming off of it. Now, I will give you a warning. The most fumes that come off of this process are a bit more on the invisible side. So just because you don't see any fumes doesn't mean that there's no danger involved with it. So you still have to have good ventilation, and again, or a respirator, things of that nature, just like we talked about before. And also, you could weld basically any metal that you could think of. You could weld it with TIG. And not only can you weld it with TIG, you can weld it with high quality. For example, other processes, they have a little bit of trouble welding on, for example, titanium, or cast iron, chromoly type tubing, any metal that you could think of. TIG, you could do it on, which is another reason why a lot of the custom work is done with TIG, because you're always going to get a much more precise weld. Something that's not listed on this list of advantages as well is that you could weld on very, very, very tiny, thin material, right, without actually blowing through or ruining it. Again, if you know what you're doing. When it comes to this process, we do use something that's called a filler metal. Unfortunately, I don't have one here. However, it's basically you hold the torch with one hand, and with the other hand you're holding what's called the filler metal. And these filler metals will change depending on what it is that you're welding on, because you always want to match the filler metal to the base metal. And so you're grabbing the filler metal, and as you're heating up that plate, you're introducing some of that filler metal in there. Now there's different techniques. For example, you could be dabbing it, or you could be using the on the wire technique, which is what we're going to be using in this class. And so you could even, if you don't want to use filler metal and you just want to kind of burn the metal, you could also do that. It's called fuse welding. And so that's another advantage of this welding process, is that you could even weld without adding filler metal, as opposed to other welding processes where you're forcing yourself to actually use that filler metal. And of course, we could weld it in all positions, much like any other welding process. So that's not so much unique, but it's still an advantage nonetheless. Some of the disadvantages associated with this welding process is that it tends to be a bit more on the expensive side. Both for the actual welding machine itself, for the materials, right, for that filler metal, for the torch itself. You're going to find out that torch is way more expensive than for example, an electrode holder used for stick welding. And so it does tend to kind of be a bit more expensive, and it's also the slowest welding process out of all of them. And so that means that our deposition rate is very slow. It deposits a small amount of metal at a time. Not only that, but your forward progress as you're doing the weld is also very slow. Another disadvantage is that it requires a higher operator skill. Again, this is the hardest welding process for most people to learn and to actually master as well. And not only that, but it's sensitive to drafts. We touched on that on our first module as well, is that with this process, you can't quite weld it with it outside, simply because there's, if a gust of wind comes in, or if you have a fan blowing towards you or things like that, it could easily blow away that shielding gas that we're using in order to get the weld done. And by the way, speaking of shielding gases, we use argon. We use 100% argon. Argon is special because it disperses oxygen. And so as our metal is molten, as it's in its liquid state, because we superheat it to a pretty high temperature, when it's in that liquid state, oxygen can easily get inside of it and cause porosity. And so as we're welding, and we have that liquid state of what we call the puddle, the welding puddle, we're blowing argon right on top of it, and we're shielding it. We're basically dispersing all the oxygen out of the way, so that way by the time we're past that part that we welded, this part's already cooled off. It's not liquid anymore. And so by that time it's in its solid state, and so when oxygen hits it again, it doesn't affect the weld. Okay, and so that's what we're going to use. If you ever wondered why they call this process heliarc welding, it's because we use they used to be using a shielding gas called helium. I'm sure you've heard of it for quite a while. That's what they used initially, but eventually the industry switched over to using argon. For one, it's a lot more economical and a lot cheaper to use, and you still get a very good weld to go along with it as well. In this class, we will have a total of 8 welding positions. Our first 4 positions will be T-joints, is what we call T-joints, which is what you see here. It's basically a piece of plate that we grab, and then we basically just put another piece of plate of the same size right on top of it. As you can see, it looks like an upside down T, and so that's why we call these T-joints. Again, it's a type of joint. The type of weld that goes on these joints, if we have the plates like this is a 90-degree angle. And typically when you're welding in that 90-degree angle, again, much like you see in all of these pictures, notice that where the weld is at, it's a 90 degrees. That's what we call a fillet weld. And so we have 4 different types of fillet welds, one for every single position. The 1F position is what we refer to as the flat position. 2F is horizontal, 3F is vertical, and 4F is overhead. The number that we see here, 1, 2, 3, and 4, that refers to the position itself. So anytime you hear 1, it's always going to be flat, 2 is horizontal, vertical is 3, and 4 is overhead. And then the F, as you might have guessed, that stands for fillet welds. And so that's what you see here. On the bottom here, we have grooved welds. We're not going to cover these at all today, simply because this is something that we're going to do on the second half of class, and I'll cover those in a lot more detail a bit later on. For now, please memorize these positions, because if I ever ask you, hey, what position are you working on? I don't want you to give me hand signs or things like. I want you to tell me, hey, I'm working on 1F, 2F, 3F, or 4F. Or if I go on that first day of class, we're not going to start on T joints right away. However, later on, I'll ask you to start on a particular position. And if you don't know what position that is, then you're going to be in a bit of trouble. So again, memorize these positions. I wish I had one in front of me to kind of show you, but 1F is like this. It's almost like a V. 2F is this way. 3F is this way, right? When we always weld uphill when it comes to this process. We never weld downhill, so you would be working from the bottom to the top. And then 4F is similar to a 2F, but it's upside down. Okay. So again, memorize these, draw these out if you need to, if that's going to help you out. So I gave you a supply list on your syllabus, and I even might have made a recording over it as well, talking a little bit more about it. But part of that supply list is buying all of this equipment that we see here. And so starting off, we're going to start off with our torch here, right? So this is how our torch looks like. When you buy it, it's probably going to look something like this if you bought something like a kit, right, where everything already comes together. If you bought things separately, it might look a little bit more like this, and actually it'll look like this, just this top part here. It'll look just like that. And so then you have your hose over here. This hose, it doesn't matter whether you screw it on from this side or the other side of the hose. They're both the same thing, but it's just a simple screw on. Make sure that that's nice and tight. And then after you do that, you just get your handle and you just push it up against that rubber mount there, and it should be quite secure after that. Okay, so this is your hose, right? Again, always verify that it says 17FV. That's the model number. 17 is the size of the torch. F means flex, meaning that this tip, see how we kind of bent it a little bit there? So when we're welding, we could flex this into the position that we want, making the welding process a bit easier. And then the V stands for valve. So this is what the valve is. And so on the other side of your torch, you will hook up to our argon system. And while you're welding, you want to have that argon on, meaning that you have to turn this knob on. And then when you're done welding, right, when you stop welding, you want to turn this off. That way you're not just wasting argon as it's coming out of this torch. And so that's kind of just the basics of what this is. After you have this, which by the way, this is what we call our front part, the side that doesn't have a valve, and then the back end is the valve side. So I tell you that because now I'm going to assemble it. That way, as you're at home, if you have your materials already, or right when you do get your materials, follow along with me as we build this up. Next up is what we call the cullet, which looks like this. If you notice, it has a little bit of a slit on one side, and then it's a bit fatter from the other side. Might be a little hard to see, a little blurry, but you get the picture here. The side that has the slit on it, that is simply just going to be dropped on the back end of this torch. That's the way that goes. Then we have our gas lens, which looks like this. This is our gas lens. This just simply screws on the front side. And this actually, again, it's very, very basic. You just, again, you put it on here and then you just screw it on. Nothing too difficult there. This is our cup. This one is a bit damaged. As you can see, they are made out of ceramic. So they will get damaged from time to time, or they'll get shattered. This particular one is a number 10. However, you were asked to buy an 8, 10, and 12, at least 2 of each. For now, just for your first day, I would just start with this number 10. 10s tend to be a bit universal. They could really be used for anything. So just start with a 10 just to start things off. Then we have our insulator. It's not listed on the picture that you're seeing there in front of you. However, I'll tell you a little bit more about it here in a bit. Then we have our back cap, which look like these. These come in different sizes. Because you are buying brand new tungstens, Tungstens must be able to fit inside your torch because of how long they are, and so you will be required to buy one of these. When it comes to these, they do sell them in about half the size and then just a little bit of like a stub kind of size. If you bought any of those other two, your tungsten is just not going to fit on there because it's a bit too long. So make sure that you have one of these longer ones here. So how do you assemble this thing together? So one of the first things you want to do is get your insulator. Again, if you don't have an insulator, don't worry about it. In my opinion, you don't really even need it. But I'll still teach you as to how to assemble your torch with the insulator on it. So that just goes in the front. Might be a little bit tricky because once you take your finger off of it, as you can see, it'll fall. So you might have to hold it with one hand, and with the other, you just simply put your gas lens in, and then again, it's a screw on, right? As we said earlier. So you just screw that on. There we go. Again, make sure it's real nice and tight. Tighten it up as much as you can. Just don't use any pliers or anything like that because you can damage the threads here if you do that. So just get it as tight as you can with your hand. After that, we're going to get our cullet, and we're going to get the side that has the slit on it. And the slit side, we're going to drop it through the back end side. Boom. Just like that. That's it. After that, we want to put our back cap on, or our tail, or our cap. And again, this is just a screw on. Do not screw this one in all the way. Just have it loose on there, just like this. So don't tighten it up. Keep it loose. After that, we're going to get our cup, which we said we're going to use a number 10. And you simply screw that on. And make sure this is real nice and tight. So as you can see, as we squeeze this cup on here, what it did is that this insulator got pushed back. And if you look at it from the back side, this insulator is meant so that no leaks can happen. However, the reason I don't use an insulator is because as long as you have your gas lens on there tight enough, there's just no way gas is going to escape from this backside. And the same thing with your cup. As long as your cup is on there tight enough, it's just not going to happen. And maybe it's just me, maybe I'm just crazy, but also it feels that if you do have this insulator, your torch does tend to stay a little bit more on the hot side because it's kind of preventing air from cooling it down in there. But who knows? I haven't scientifically proven that yet. But that's what your insulator is for. Last but not least, when you buy your tungsten, it will come in a pack of 10. And so with this particular tungsten, and even the tungsten that you see in front of you in that picture, notice it's pretty sharp on both sides. Yours is going to be dull on both sides, and it's going to have a red band on one side. That red band just indicates that it's a 2% thoriated tungsten. And don't worry about that quite now, about how mine is a little bit sharper and shorter. Don't worry, I'll get to that as to how you get your tungsten ready to start welding. But for now, just know that you're just going to get your tungsten, and you should see a hole. I know you guys aren't probably going to be able to see it, but there is a hole in there. Just put that tungsten inside of that, and you should be able to firmly be able to easily push that tungsten in. You're going to have it about maybe half an inch to a quarter inch outside of this cup. That's what we're going to refer to as our tungsten stick out. So our stick out is going to be somewhere around that area. Just hold it with one finger like this, and with the other hand, tighten up this tungsten. Once you tighten up the tungsten, if you remember that slit on that cullet that we had, as you're tightening it up, that slit is getting closed up, and so it's clamping this tungsten in place. And so as a result, if we tighten it up properly, again, we can't take this tungsten out. Whenever you need to resharpen this tungsten, which we'll get to that here in a bit, or you need to remove it for whatever reason, just loosen this up again, just a little bit. Now look at that, right? You could easily take it out. But when we're welding, just keep it tight, and that's it. That's how you assemble your torch. On the very first day of class, the very first day that we go out there and weld, I will ask that you hook up all your equipment, including, put your torch together and all that. And then I'll go in there and I'll give you an equipment setup grade. And I'm just checking to make sure that your torch is hooked up properly, and also that you have that you're appropriately hooked up to our to our gas system and that you have the right amount of argon coming to your torch, which again, I'll talk about that a little bit later on. But this is one of the things that I'm going to look forward to when I do take that grade. And here's a picture of that torch put together. As you can see, another picture of that nice tungsten stick out about 1/2 inch to 1/4. So how do we get that tungsten ready? And so, like I said again, when you buy yours, they're going to be brand new. And so yours aren't going to be sharpened up. We have to sharpen them up. Inside of our welding area, we're going to have 2 bench grinders, which if you don't know what a bench grinder is, this is basically what it is. You know, you could kind of see a little bit of it. But it's basically a tool that you're going to use where you're just going to easily turn this equipment on, and I'll train you on how to do that. And then you're going to get your tungsten, your brand new tungsten, and you're going to put it up to the wheel, to the face of the wheel, which is this front side, just like this. And your goal of doing that is to have that wheel grind up against that tungsten, and eventually it's going to make it look like a pencil. The very tip, that's your goal. You want to make that tip look like a pencil. As you can see on this picture, they're sharpening it up. All right, that way. Do not, if the wheel is spinning, let's say, like they have it on that picture, notice that tungsten is vertical like this. Do not put that tungsten on its side as that wheel is spinning like this. Because if you do that, notice how it's going to make small little abrasions on your tungsten, sideways abrasions. And when you start welding, the electric arc coming off of this tungsten, it's going to be very unstable. It's not going to be very accurate. And so that's why when we're sharpening it, it needs to be with the face of the wheel. Just again, just like you see it on this picture, that's how it has to be, not held sideways. So that way those abrasions could go up and down parallel to the actual tungsten, and that's going to give you a much sharper, a much better arc as well. So once you sharpen it, also make sure you sharpen both sides. Don't just sharpen one side. Don't worry about removing that that red band from your tungsten. It's not going to affect anything. But once you have your tungsten sharpened, put it back inside your torch, and then as you start welding, a little bit later on I'll teach you how to get started. As you start welding, your tungsten will get dull or it'll get dirty over time. And so as this starts to get dirty, or you notice that it's not as sharp as you once had it before, take your tungsten out, switch it to the other side because you did sharpen both sides, right? And then use the other side. Once both sides get dirty or dull, remove this tungsten completely, go up to the bench grinder and just keep resharpening it. And as you can see, over time the tungsten will get smaller and smaller and smaller. That's why you see that this tungsten is a bit on the small side. Now, a lot of students always ask me, well, when do I throw it away? Like, how small can I get this? And the answer is, well, as long as you're still able to safely sharpen it, and that's a key word, safely sharpen it, then you could basically just have it as small as you need to. It's always going to fit on your torch and it's always going to stay there. And so when it starts to become unsafe to sharpen the tungsten is when your tungsten is so small that you could just barely grab it and your fingers are real close to the wheel. And as you could imagine, that's going to pose a bit of a safety hazard, right? If your fingers are basically brushing up against the wheel as you're sharpening it. So you could basically use them as long as you need to. Just don't put yourself in danger just to sharpen them up. So as I showed you before, on one side of your torch it'll look like this. If we go over to the other end of the torch, it looks just like this, just like we see on the picture here. So we have our power bank connector, which is this part right here. And then again, if yours is already pre-assembled, then this rubber boot is what we call it. This covers this section up here. And so there's 2 connections on this power bank. One is what we call a male quick connect, just like this. Inside of your booth, you're gonna have a female quick connect just dangling in one of the corners. You're gonna get your male and you're just basically putting it inside and then giving it a twist in order to basically just quick connect it. The other connector is this part right here. Again, this is a screw on, it's not a quick connect. And so what goes in here is one of these green hoses. In your booth, it's probably either going to be a green hose or a black hose. Either way, it doesn't matter. You're going to connect that hose coming off of one of the two flow meters inside of this part here. And so let's move on and let's talk about what this is right over here on the right side. Inside each of one of your booths, you're going to have this exact same setup, exactly the same. Just like I said, the hose color might change, but everything else is exact. If we start from the very, very top here, we have this lever here. Basically, and when you see this lever, you're always going to notice that it's sideways, right? So if we see that this pipe here, it's vertical, this is horizontal, that means this is it parallel? No, right? It's perpendicular to the pipe. And so when it's like this, that means it's in the off position. What you're going to do is that you're going to flip this up. Again, once your torch is already hooked up, don't turn this on if nothing's hooked up to this hose down here. Hook everything up and then you start messing with this. And so first thing you want to do is pull this lever up. So you're going to get this lever and pull it up like this to where it's parallel with the pipe. Once that is on, argon is going to be shooting down this pipe and it's going to be going to this flow meter, and then it's going to also be going to this flow meter. Depending on what flow meter you're hooked up to, so again, you're going to follow your argon hose, whichever side that you have hooked up to your power bank, that's the one that you are going to want to use. So for example, in this particular picture, we're hooked up to the top one because that's where the green hose is at. There's nothing even hooked up to this bottom one. And so in this case, do not mess with any of this here if there's nothing hooked up to it. We're only going to mess with this part. So after again, we're just kind of following the argon flow here. It's coming down the pipe, then it's going in here. From here, you want to turn this knob on. This is not a knob to where you have to set it to a particular distance or anything like that. You're basically just, this is either going to be on or off. Okay, so either make sure it's tight to where it's off, or turn it on if you're going to use it. Turn it on, turn it on, turn it on. Once that's turned on, argon is going to flow now to our flow meter, and you're going to see a small little shiny silver ball, and you can kind of barely see it on this picture here. As you start turning this knob, this is what sets your flow rate of argon. On your flow rate, it needs to read 20 to 25 CHF. Again, I would write that down. 20 to 25. This is going to be part of your equipment setup. So turn this on until, again, you see, as you turn this on, you're going to see that little silver ball. It's going to start to rise, and you want that ball to stay floating between 20 and 25. One last thing. This is called the flow meter. It is called a flow meter because it measures how much flow of gas is flowing through it. And so if you're sitting there trying to adjust your flow meter by using this here, but you don't see that ball going up or down, it means that you have this valve shut off, because you could turn it out here on as high as you want, but if no argon is flowing through our system, that ball is not going to do anything. So make sure that you turn your valve on. Once you turn it on, you're going to notice that this ball is going to start floating around where you need it to. Okay, so again, 20 to 25. Whenever you're welding, again, have this on without a doubt. However, whenever you stop welding, instead of going over here and start messing with all the valves, just turn it off from here. And when you turn it off, you're going to notice that ball, it's going to go from 20 to 25, wherever it is that you have it set, and it's going to stop dropping real slowly until it reaches 0. If that ball drops but it never reaches 0, for example, it stays floating around, for example, 10 CFH, it means that you have a leak somewhere. It means you don't have something hooked up. Typically, most students, when they screw this argon hose into their power connector here, a lot of the times they just hand tighten it. You can't just hand tighten it. You're gonna have to get your pliers and tighten it up real nice and tight. or channel locks or something. If you don't have something to tighten that up, let me know and I'll help you out with that. But eventually you are going to want to get your tools in order, you know, for you to be able to do this on your own. So we know how to use our equipment. So now we have to prep our material. Now we're not going to start on T-joints right off the bat. We're going to start on bead pads. Bead pads is basically just a piece of metal to where you're going to practice running a bead. A bead is just simply a weld. We can use those interchangeably. And so in order to get started on this, you're going to need a scrap piece of metal, meaning that we're not going to cut brand new metal for bead pads. You're going to go to the scrap bin, which once we're out there in the lab, I'll show you where that's at. You're going to get that piece of scrap and you're going to grind it down. You're going to use your grinder to completely grind it down to where we have nothing but nice shiny metal, similar to what this picture is over here. So this is a good example of what that metal should look like. And then down the center, you kind of see a little bit here. This is an example of how it should not look like. Notice how there's a big distinction between this metal that we have grinded down and this over here. So in this case, you would need to grind down a lot deeper to where we have, to where all of the surface of this scrap piece of metal looks similar to this right over here. Okay, so that's how I need you to grind it down. And when you do grind it down, don't use your 1/8 grinding disc. I would suggest you use your 1/4 inch grinding discs, and those will work just a little bit better. And that's it. That's all you have to do for this first day. And then once you finish out your bead pads, again, we're gonna do bead pads in every single position. So you're gonna do bead pads on the flat position, and then you're gonna do them on horizontal, and then vertical, and then overhead. So the very first position that you're gonna be working on is the flat position. When you do set up inside of your booth for the flat position, I want you to place these bead pads about waist high. So don't have that bead pad like way up here inside your booth and then you're sitting there welding from the top side. You have to have it about where your waist is at. And then as time progresses and you start moving up to the other positions, I'll let you know where you have to have it placed at. And so that's the first thing that you're going to do. Once you start on your T-joints, we're going to have to start cutting flat bar. Now, I would write this down on your notes because this isn't something that you're going to do immediately. You're going to do this maybe about 2 more weeks. And so by that time, you might forget a lot of what's being said here. So when you do get to T-joints, you're going to cut, just like it says here, cut a 2-inch piece of flat bar and 2 1-inch pieces of flat bar, right? And so as you can see, we measure flat bar by how wide it is. So this is, you know, about 2 inches. This is probably a 1-inch flat bar. This might be 1/2 inch, and so on and so on. In our lab, we only have 2 different sizes. We have 2-inch flat bars, which are the wider ones. Then we have 1-inch flat bars, which look like this. Okay, so again, make sure you write that down. And then the way that you're going to prep these flat bars is that just like you grind it down to surfaces or one side of this bead pad, you're going to do the same thing to the flat bar, both on the front and on the back side. So we have our bead pad in front of us. We're going to start on the 1F position, meaning it's near our waist area, right? We have everything set. We have our tungsten is sharp, our argon, our CFH is flowing. Everything's good. So how do we even get started with this? Let me put my tungsten in here back real quick. How do we get started striking an arc? Unfortunately, I'm at home right now, so I don't have a filler metal, but here's what I'm gonna do. Let's pretend that my tungsten is still in there. And we're gonna pretend like this is my filler metal and my tungsten is still in there. Okay, so just bear with me here. So, if you're right-handed, you're gonna wanna grab your torch like this, to where you get this part of your hand and you just kind of tuck it right up in there. And of course, you're wearing gloves at this point. And so you're tucking it right in there. Also notice how the tail of the torch is kind of touching my hand as well. If it's not touching it, remember you have a flex head, right? We bought a flex head, and so you're able to bend this to where, right, in that example, we need a little bit more. There we go. And so boom, this is how you want to hold the torch. When you're on the flat position, you're gonna have that again. Let's pretend we're waist high here and we're on a flat surface here. You're gonna lay the cup, so meaning this portion here, the very tip of this cup, we're gonna lay that down on our bead pad. So boom, this is our bead pad, we laid it down. Do not, and I repeat, do not allow your tungsten, right, because let's pretend we have our tungsten in there, do not allow that tungsten to touch the metal, because if that tungsten touches the metal, it's gonna strike an arc. It's gonna, you know, have that that famous bright light. And we also said that we always need to be ready, have our welding hood on and stuff before we actually see that. And so do not let that tungsten touch the base metal for that reason. And also, if your tungsten does ever touch your bead pad, your base metal, it's not going to be very dull because of it being so sharp. If it touches, as you try to bring it back out, a piece of that tungsten is going to stay stuck on that bead pad, and that creates a few issues. One, it creates tungsten inclusion, which is a new type of defect that you just learned about. Tungsten inclusion is when a piece of tungsten gets trapped inside of our base metal. If you ever shoot x-rays on your weld, right, to examine it, whether it's a good weld or not, they're going to be able to see that you have tungsten inclusion in there, and you could get fired for something like that. And so how is it that we could make an electrical connection between our tungsten and our base metal without them touching each other? How are we going to do that? Because that's the only way that we're going to be able to turn on our weld or strike an arc, is the proper way of saying it. So how are we going to do that? So remember that we also use a filler metal for this process. And so what you're going to practice doing on your first day, again, once we're in position, we're laying on the flat there, you're going to get a filler metal, a piece of filler metal. It don't have to be a real big one. It could be just a real small one. Maybe even just the size that I'm holding here, right? It could be something small. And what you're going to do is that you're going to scratch start this process here. And so what that means is that you're going to rest your filler metal on that plate, just like this, while this is resting here, and you're simply going to just scratch it like this. So when you do that scratching motion, as you're dragging that filler metal, it's touching the plate. It's also at one point, right, for a split second, it's also going to touch that tungsten, and now we have an electric connectivity between the tungsten and our plate without those two touching each other. And so that's what we call scratch start TIG. And of course, before you do strike that arc, make sure that you have your welding hood down. Now, although that may seem easy to do, remember, once you have your hood down, unless your hood is auto darkening, which I recommended that you don't have, and so I'm assuming that you don't have an auto darkening hood right now. So when you pull your hood down, everything is going to be pitch black. You're not going to see anything. And so you're going to feel a bit silly in the beginning because you're going to be doing this, and right, you're not going to be able to do touch what you need to be touching at once. So it's going to take practice. You may get a little bit frustrated, but just kind of hang in there. Again, I'll be there by your side. So if you need my help, just come out of your booth, ask for help, ask me, hey, is there an easier way to do this? And there's a few tricks I could show you to kind of get a little bit more of used to striking an arc. But that's how we're going to strike an arc in this class. I don't ever want to see you tapping that tungsten on the base metal. So we struck our arc. Now how in the world are we going to make a nice looking bead like the one that we're seeing here on this piece of metal here? It's a bit hard to show you. Typically, if we were in class, I wouldn't be welding in front of you, but I would be inside the classroom and I would be showing you how to manipulate that cup. And so the very first technique that we're going to learn in this course is walking the cup. If you could imagine walking the cup it's similar to grabbing a huge, let's just say 55-gallon barrel on the floor. How will we move that barrel from point A to point B? Are we just going to pick it up? Probably not, right? It's going to be way too heavy. And so the best way to move that barrel would be to tip it on its side. So we have this bottle of water. Let's just say, again, this is the front side of our cup here, right? Where we get that barrel, we would tip it on its side, and then we'd kind of roll it like this. We'd roll it one side, and then we'd pivot it, roll it, pivot it. This, what I'm doing here, this is called walking the cup. Notice that we're advancing forward. However, are we lifting that barrel or when we're welding this cup up? Absolutely not. There's got to be a better way to show you guys. All right, let me try this book here. All right, so we have a flat surface. Boom, we rest our cup. This is what walking the cup is. Notice how that cup is never being lifted from that book. However, we are still slowly advancing forward, All right, we're slowly moving forward. This is what walking the cup is. I would suggest that once you have your cup or your torch put together, grab that torch, grab yourself, go to a flat piece of surface, or even grab a or your book on your book itself, and just practice doing this. Practice doing this at home, because this is very elementary when it comes to this process. Walking a cup is, and so what you don't want to do is come to class and then have yourself do this for the very first time in class, because you're gonna waste a lot of time muscle training your hand, and training your mind and stuff to get used to that motion, because it is a bit hard for some people. Some people it'll come easy, some people it's a little bit harder, but you definitely don't want to waste a whole lot of time in class. This class in particular does tend to rush students on it, and to me it's by far the hardest intro class to do, because there's just so many welds to do, and like I said, this process is very, very slow. And so with that in combination with the amount of welds that you have in here, you're going to run out of time. So you don't want to come to class doing this for the very first time. Practice at home. If you still don't have your equipment, grab yourself a cup or anything that's round, and just, again, you might feel silly, but I'm telling you, it's going to work. Just start walking a cup on a flat surface, right? As you're watching TV or as you're on the internet, just with the other hand, just walk the cup, right? You don't even have to be looking at it. You want to get to the point to where you could walk that cup without even looking. Now, as you're walking that cup, again, you have that tungsten in there. Where the tungsten is where that arc is coming out from. And so as you could imagine, you're going to be making similar to what like a number 8 figure over and over. So it's like you're making a number 8 over and over and over. That's kind of what the motion translates to. And I know it's a bit hard to see on this PowerPoint or on this picture here, but I'm sure you could just barely make out the bead pattern that's being made here. So if we have a consistent bead pattern, that means that you're walking a cup consistently. Also, as you're walking a cup, you're looking at the edges of the bead, making sure that those edges are staying straight and that they're matching each other. So how does that look like? How does it look like when we're actually underneath that hood and we're looking at things? So this is how that looks like there. This molten pool, this is what we call our weld puddle. Just like this. This is, of course, the arc. You should never be looking at the arc, not because it's damaging your eyes. Remember, we have our hood on, so it doesn't damage your eyes. However, your arc is never going to tell you anything. The only thing you need to be looking at when you're welding is your puddle. Now, in this case, whoever's welding this, they are going a bit on the fast side. You're not going to be going this fast at all. You're going to be going a lot slower, because you need to get used to for one, the motion. So just kind of take your time with it. Not only that, I want you to focus more on the quality aspect of welding rather than focusing on your speed. Speed will come with time, so don't worry about being a fast welder for now. So as we're looking at this puddle, notice how every time he or she goes to the edge, Notice how those edges are lining up with each other every single time. Same thing on this side. Those edges are lining up with each other every single time. And those edges are being made by the edge of the weld puddle. And so as you go from one side to the other, that's what your eyes need to be looking at. So in other words, your eyes are bouncing from one side to the other. So they're kind of doing this back and forth, back and forth. That's what we're doing when we're welding. One thing that I forgot to add, once you do strike your arc, that filler rod that you had in your hand, don't worry about it. Just put it away. We're not going to be adding filler metal in the beginning. At the beginning, we're just practicing on this motion of walking the cup. Once you get good at that, then I'll show you how to start adding filler metal on a one-on-one basis. So run a few of these beads. And when you do run these beads on your bead pad, once you lay one down and you're getting ready to lay the next one down, put it right beside your previous one. Because if you have a bead here and then you jump around, you put one way over here, or you put one going this way, by the time you know it, you're going to run out of space to run any more beads. And so you're going to find out that, I mean, it's going to take you quite some time to clean up this bead pad. And so just for you to put 1 or 3 welds on it, it's just not going to be worth it. So try to keep all your welds basically overlapping each other as you're creating this bead pad. Once you get good at your flat position, you'll come show me, right? Or if you need help, of course, come show me. But once I see that you're consistent, your beads are looking nice and straight, your edges are looking good, then I'll tell you, okay, go ahead and move on to the horizontal position, and this is how you do it. Okay, so I'll show again. It's a lot of one-on-one training that's going to be going on here. But first, again, we all got to start somewhere, right? We're all starting with bead pads without adding filler metal. Once you finish all 4 positions, flat, horizontal, vertical, and then overhead, once you finish all those 4 positions in bead pads, then you're going to do them over again, but this time you're going to be adding filler metal, and again, I'll show you when it comes time to do that. Oh, and one thing that I want you to write down, on your control box, you're going to set that at 50 on your control box. If your class is in room 111. If your class is in room 112, you're going to set your control box to 70, and that's it. So it's either going to be 50 for room 111 or 70 for room 112. Again, same picture here. And then here's kind of a little bit more of a close-up look of what a bead should look like. So don't pay attention to the color for now. We'll discuss color a little bit later. It's a little bit more of an advanced sort of thing. For now, I just want you to focus on having a nice looking bead. And on here, you can clearly tell that, man, this bead pattern is really, really consistent. Notice the distance between each of these beads. Right, it's consistent. It's the same basically from start to finish, and that's one of the things that I'm going to be looking for. Another thing I'll look for is making sure that your edges are really nice and aligned with each other. If we really wanted to nitpick this particular weld, we could see that these edges, see how it's a little bit like a cloud shape here along the sides? So that means they didn't do a very good job lining up their edges. But for the most part, this is a pretty solid looking weld. So you finished all of your bead pad positions. Now it's time to do T-joints. Go ahead and write all this stuff down that's listed here on the side. When it comes to T-joints, like I said earlier, you will cut 1 2-inch flat bar, which is this piece that you see right in the center, and then you're going to cut 2 1-inch flat bars. One of those flat bars is going to go here on this side, and the other is going to go on the other side. So how are we going to put these together? So before we actually put our main weld on this thing, which you could see exactly where the weld is going to go for the flat position here, we need to tack these pieces together. And the way that we do that is that we're going to get this 1-inch flat bar, this 2-inch flat bar. We're going to lay the 1-inch flat bar in the middle of it, and then we're going to put on here what's called a tack weld. that tack weld is going to go here on this edge, exactly where my mouse cursor is at. That's where I want it to be. As a matter of fact, let's see. It's going to go right here, right where that laser pointer's at. Okay, so once you tack it on this side, you're going to go over to the other opposite side and tack it in this exact spot, but on this side. So now we have this part and we have this part. After that, you're going to place this other flat bar on the other side, and you're going to do the exact same thing. This time you're going to tack it here, you're going to tack it, and then you're going to tack it on the same exact side on the opposite side. And so now we have what looks like a plus sign, right? In this case, it's an X because we're in the flat position. And just like before, you're going to place this about your waist area, and you're going to be welding down in that flat position. And same thing for 2F, it's just that the position is the only thing that changes. 3F vertical, remember we always weld uphill. 4F is the upside down version of 2F. This is our very last slide on here, so hang in there. Go ahead and write all of this stuff down and label it T-joints. So in this illustration, we have the flat position, because remember that's that X position like this, and we're welding on this top V side. And so again, this looks like a V. The very first pass that we put on here, we're going to call it the root pass, which is this pass right down here. Again, you could see it has a little bit of a convexity to it. This is it. Our second pass is our hot pass, which looks like this. And then our third pass, we'll just call it our cap, right? Which is our very last pass. We're going to put that on there. And this is it right there. So in total, you're going to have 3 passes. As you could see your temperature is 50 on your control box if you're in room 111. If you're in room 112, we're going to set our control box to about 70. As far as what shuffling the cup is and using your filler rod and that stuff, don't worry about that right now. Once we get to it, I will cover it with you a bit more one-on-one. So don't worry too much about that. The only thing, just kind of minimally here, shuffling the cup is different from walking the cup because we're inside of a V groove, right? Because we're inside of that V groove, that V, once we place our cup in here, we can't walk the cup because we could only walk the cup on a flat surface. So in order to move our cup forward as we're inside this V groove here, we have to shuffle the cup, and that's what I'm referring to there. So distinguish the difference between walking the cup and shuffling the cup. Those are 2 separate techniques. And then later on, I'll show you how to use the freehand technique, which you will use once you start welding on pipe. But let's be patient here, 1 step at a time. So again, get this, have those notes ready with you, have it written how much CFH you're supposed to have. That way when I do go over to your booth and I ask you to show me your equipment, show me your torch, show me that you do have set the right CFH, that way you'll get 100% of those points. If you have to ask me questions in order to set something up in terms of your equipment setup, I'll start deducting a little bit here and there. So again, guys, good luck, and I hope to see you soon.